Okay, the next thing I'm going to talk about here is something called equivalence. Okay, now this is the symbol for it. It's like the implication sign, but with an arrow on the other end. Okay, now as a sentence, this means if and only if. So for example, let's use the example of the idea of getting into that club, right? So let's say P was I'm wearing a tie, so I am wearing a tie. Q is I am wearing smart shoes. Now, a better rule for the club is if you want to ensure that people are wearing a tie and smart shoes, is to use an equivalence instead. Okay. Now, how I'd write P and this symbol and Q would be like this. I am wearing a tie. Let me just shorten it to that. If and only if I am blah 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 wearing smart shoes. Okay, so you have this. Then when you see this, it means if and only if, and then you copy the second statement in there. Okay, you could have something like P, if and only if not Q. Right, so you could have something like that. So you'd put the opposite into this statement. So as soon as you see this double-sided kind of arrow, it means if and only if. Okay, now let's look at the truth table behind it. Now, what P, if and only if Q actually means, it literally means this. It means P implies Q and Q implies P. Okay, so it means if you're wearing a tie, then you are wearing smart shoes, and if you're wearing smart shoes, then you're wearing a tie. So literally, that's what it means. Okay, so that's equivalent to that, and you can prove that if you want later. But let's look at the truth table behind this. P, Q. Just do it really quickly. And P, if and only if Q. Now it's sort of like this: true, true, false. Oops. Let's keep it consistent. True, false, false, true, false, false. Okay. It only works. I just want you to remember this because it's kind of hard to explain. But if the two symbols are the same, then it's true. Okay, so if you're wearing a tie and you're wearing smart shoes, then you're allowed in automatically. If you're not wearing a tie and you're not wearing smart shoes, you still should be allowed in. However, you can't have a mixture of both, so you can't go in if you've got a hat on. Sorry, if you've got a tie and you haven't got smart shoes on, or vice versa. Okay, so the way to remember this one is that if they match each other, then it's true. Okay. However, if both of them are like opposite to one another, then it's false. Okay, so that's the way I remember it. Okay, so if they are matching one another, then it's true. But if they're the opposites of one another, then it's false. Okay, so it's kind of like this would be a better kind of thing for the club. It would be like if you come with a tie, then you better be wearing smart shoes. Vice versa, then don't bother coming. Or if you haven't got a tie on or smart shoes, then technically you're still allowed in. So that's the idea behind equivalence. Okay. If that doesn't make sense to you, I want you to remember this rule: that if they match each other, then it's true. Otherwise, it's false. Okay, that's probably the easier way to remember it. Okay, so that's equivalence done. Now you could have things like P, if and only if, not Q. Remember, you'd need to do a not Q column and then you'd have to compare them both against each other. So, it builds on all the prior stuff we've discussed. Okay, so I'm going to